Right. Let's begin the do now for the hopefully you started the do now already. So let's think of two numbers whose product is negative 27, but at the same time, the sum of those same two numbers would add up to 6. Those two numbers, negative 3 and 9. Negative 3 times 9 is negative 27, and negative 3 plus 9 is 6. Let's take a look at the second set. We need two numbers whose product is 25 and sum is 10. And that would be 5 and 5. 5 plus 5 is 10. And 5 times 5 is 25. On this next step, it says to factor each polynomial. Write the prime factorization of each term, like so, and see what numbers and variables match up. Both have a 3. And they both also have a b. So that means we can factor out a 3b. And remember, this step is optional. You may be able to see it, and we could go straight to the answer, 3b, and that leaves us with 2 plus 3b squared. Remember, b times b is b squared. Let's take a look at the second one, and let's write the prime factorization for this binomial. So we're going to write down 2 times 2 times 3 times d times d times d times d minus 2 times 2 times 2 times d times d. Notice we have two 2's in common, and we also have two d's in common. That means, again, this is optional just to show you, and we can factor out that 4d squared, and that leaves you with 3d squared in the first term minus 2 in the second. All right, we're factoring, and notice the coefficient for this one is a 1. So we want to solve this quadratic by factoring. So we're going to go 1 times 18, which gives us 18. So again, what two numbers multiply to give us 18, but when we add, we get 11. And that would be 2 and 9. You don't have to do the long steps by factoring by grouping, since the coefficient, the leading coefficient in this particular problem is a 1. We could simply write down x plus 2 times x plus 9 is equal to 0. Now we're going to solve. We're going to use a zero product property. Remember, if we're multiplying two terms and the product is 0, at least one of the terms have to be equal 0. So we're going to set the first term equal to 0, solve, and then set the second term equal to 0 and solve. So our answer is negative 9 and negative 2. And let's remember what this negative 9 and negative 2 actually means. It means when we plug in negative 9 into this equation, we will get 0. Or when we plug in negative 2, we will get 0. Sometimes you'll see people say, hey, find the solution for the quadratic, and it's finding the 0 or the root. Later on, we'll say we're finding the x-intercept. So remember, the x-intercept is when y is equal to 0, and you'll see that relationship in the future. So let's take a look at the next problem. The leading coefficient in this particular problem is a 1. So 1 times negative 21, that's going to leave me with negative 21. Numbers multiply to give you negative 21, but add to give us negative 4. And that would be negative 7 and 3. Leading coefficient is a 1. We could simply write x minus 7 times x plus 3 is equal to 0, and then we can solve. Set the first term equal to 0, and then set the second term equal to 0. And we have our answer, 7 and negative 3. All right, let's take a look at the next do now problem. And notice that the leading coefficient is no longer 1, that we're going to have to do more work. We're going to have to show the work, and we're going to have to factor by grouping. So 3 times 35 is 105. So now we have to think of what two numbers multiply. You might want to write the prime factorization of 105. What I did was I knew it was 35 times 3. So I said, hey, what are some factors of 35? And I noticed 7 was a factor. So then I said 105 divided by 7 is 15, so I noticed it was 7 and 15. I'm going to rewrite this. Right? So again, this plus 22x is the same thing as this plus 7x plus 15x. So now in the first group, the red two terms, we could factor out an x. That leaves us with 3x plus 7. In the blue, in the last two terms or the blue terms, we can factor out a plus 5. Remember, we don't want to just say 5. We want to say either plus 5 or minus 5. So we're going to factor out a plus 5. That's going to also leave us with 3x plus 7. Since each term now has a 3x plus 7, we could factor out the 3x plus 7. And that's going to be multiplied by x plus 5, the remaining two. Once we have that, we can solve using the zero product property, set each term equal to 0 and solve. And the second one set it equal to 0 and solve. So now we know our answer is -5 and -7/3. And let's take a look at the last do now problem. 2 times -27 is -54. So what two numbers multiply to give us -54? But when we combine these two numbers by addition, we'll get 3. And that would be -6 and 9. Now we're going to factor by grouping since the leading coefficient is not a 1, so we're going to rewrite it. And remember, this plus 3x is the same as -6x plus 9x. So when you have a -6 plus 9, that's equal to a positive 3. So in the first two terms, we could factor out a 2x. That leaves us with x minus 3. In the last two terms, we could factor out a plus 9. And that also leaves us with x minus 3. Since both terms have our x minus 3 now, we could factor out the x minus 3. And that's going to leave us with x minus 3 times 2x plus 9 is equal to 0. Now to solve this, we're going to use the zero product property. And we're going to set each one equal to 0. We're going to use the zero product property and solve. We're going to set the first term equal to 0 and solve. And then we're going to set the second term equal to 0 and solve. And we have our answers 3 and -9/2. And that concludes the do now. Later on, I will post the lesson for today, but hopefully you take some time, review the do now, and see you on the next video. Thank you. Have a great day.